in part 1 here, we've got b equals 36, we've got x equals 3, so 36 equals k times 3 squared minus 3 cubed divided by 3, so 36 equals 9k minus 9, and k is going to equal 5 if you solve that. In part 2, it says there when the depth is 7.5, in other words when x equals 7.5, v should be 140. So let's see what our model gives us. We know that k is 5 from our previous question, so our model is this, and our value of x is 7.5, so that gives us the value of v 5 times 7.5 squared minus 7.5 cubed over 3, and that works out to be 140.25, which is pretty close, so it should be 140. I think it's fair to say that's approximately 140, so therefore the model works well. In part 3, we've got a model that relates the volume to time instead of depth. So this model is how the volume changes with respect to x, which is depth of the glass, whereas this model is how the volume changes with respect to the time t. So we now have two different models. In part A, it's saying after 5 seconds verify that the depth of champagne is between these two values. In other words, x must be somewhere between 5.21 and 5.20. So we definitely know t is 5. When t is 5, we can substitute that into that formula above. So we'll have 140, 1 minus e to the minus 0.2 times 5. 0.2 times 5 is 1. So this is going to be 140, 1 minus e to the minus 1. And typing that into a calculator will give us 88.4968 and so on. Best to leave that exact on your calculator because it's actually x that we need to do now. There's two ways of doing this next bit. You could substitute in x equals 5.20 into here and x equals 5.21 also into here, and show that this 88.4968 is in between the two answers you got. I would probably do it by solving the cubic equation, since my calculator will just do that for me. So if you write down this equation up the top here, but with v equals 88.4968, we get 88.4968. and so on, equals 5x squared minus x cubed over 3. And we could just solve this. It's a cubic equation. I'll get everything on the left. So 1/3 x cubed minus 5x squared plus 88.4968 equals 0. Now, if you use the equation solver on your calculator, it's a cubic equation. So the polynomial of degree 3, a value of a is 1/3, b is -5, c is 0, and d is that. If you solve that on your calculator, you'll get 3 solutions, and one of them will be the one we want, which is 5.206 something. I think it rounds to 5.207 to 3 decimal places, and that is between these two values that the question says. So we have now got an answer. Our answer is between 5.20 and 5.21. In part B, we need to use this formula again. So 140, 1 minus e is a minus 0.2t. Now it's possible you might not have done this yet. This is to do with rates of change. This is rates of change, which is the last section of chapter 9 in the Year 2 textbook. But if you haven't done it yet, follow along with this solution, and hopefully that will help you when you do get around to do it in class. Looking at the question says the word rate. Now, whenever you see the word rate, it means you're going to have to work out, you're going to have to differentiate something with respect to time. Okay, so you're going to have to work this out. Now, it's talking about the rate at which the depth is increasing. Okay, so we need to find this at some point. Well, that's what we're trying to find out in this question, and that's when t equals 5. So in order to work dx by dt, we need a formula that relates dx by dt with dv by dt and dv by dx. Okay, so dv by dt, that would equal dv by dx times by dx by dt. So this is what we're trying to find in this question. So if we can just work out what this is and what this is, then we'll be able to rearrange the equation and find dx by dt. In order to find dv by dx is fairly straightforward. We can just differentiate. This. So dv by dx is 10x minus, that's going to be 3x squared over 3. So that's just going to be 10x minus x squared. So that's this. That's this done. We just need to find dv by dt now. So dv by dt, we need to differentiate this formula now. So I would multiply out the brackets, and you'll get v equals 140 minus 140 e to the minus 0.2t. And then when you differentiate it, the 140 at the front is going to disappear, and you'll have minus 140 multiplied by minus 0.2, and that's going to give you plus 28. So that'll be plus 28 e, and then minus 0.2t will stay exactly as it is. so we can put this in here, and this will go in here. Before we substitute that in though, we should probably just work out when t equals 5, what does dv by dt actually equal. So if we put t equals 5 up there, that will be 28 times by e to the minus 1. So 28 times by e to the minus 1. If you type that into your calculator, you should get 10.3. Okay, so going back to this formula here, let's do it in a different color now. So we can use this formula now because we've got 10.3 equals dv by dx, and dv by dx is 10x minus x squared. And remember, we don't know what dx by dt is. That's what we have to work out. So I think we might just need to clear up a bit of space here. I'm running out of space. Just moving this up to the top. I'm rearranging, so dx by dt, which is what we're actually trying to find in this question, is 10.3 divided by 10x minus x squared. And when t equals 5, we knew from the previous question that x was 5.207 to 3 decimal places. We worked it out a minute ago. So if we put these values in, dx by dt will equal, so just substitute x equals 5.207 into here for both x's, and the answer you should get is 0.413 centimeter seconds to the minus 1. For the last part, the question is talking about volume, and it's also talking about which is faster, so it's talking about volume and time. So I wouldn't use this equation. I think we're going to need to use this equation, v equals 140 1 minus e to the minus 0.2 t, and which is quicker when t equals 70, so 2 lots of this or 1 of these. So let's work out how long it would take for 140 centimeter cubed. If it was 140 here, these would cancel, so we get 1 equals 1 minus e to the minus 0.2 t. Now that means that, let's just put this over this, so 0.2 t. In order for this right hand side of the equation to equal 1, all of this here needs to equal 0. The only way this is all going to equal 0 is when t goes to infinity. So t would need to go to infinity in order to get this total of 140. In other words, to get a glass of 140 centimeters, it's going to take infinitely long, which is not ideal when you're pouring champagne. So it's better to have 2 half glasses. I don't know how long that's going to take, but it's certainly going to be quicker than infinity. So it's quicker to have 2 half glasses. It's quicker.